Have you ever wondered how computers learn and adapt like humans? Today, we'll explore neural networks and their incredible potential. By the end of this tutorial, you'll understand how to construct and implement neural networks for various machine learning tasks. Let's break this down into clear, easy steps. First, understand the basic components of artificial neural networks. We have an input layer to receive data, hidden layers for processing, and an output layer that produces results. Next, determine your input and output dimensions. This means deciding how many features your input data has and what outputs you need. Now, choose the number of hidden layers. For complex problems, more hidden layers may be required. Then, select activation functions. ReLU, sigmoid, or tanh can introduce nonlinearities into your network. Once your structure is ready, it's time to train the network. Use backpropagation to reduce errors and optimize performance. Keep in mind the universal approximation theorem. It states that neural networks can approximate any continuous function if configured properly. Now let's look at practical applications of neural networks. They can be used for classification tasks, like recognizing handwriting. For regression tasks, they can help predict continuous values, such as housing prices. When it comes to image data, convolutional neural networks, CNNs, can identify objects in photos effectively. For time series data, recurrent neural networks, RNNs, can forecast values based on historical data. Natural language processing, NLP, tasks, such as language translation, often utilize LSTMs and transformer networks. Next, we'll discuss designing deep learning architectures. Remember, deep learning involves multiple hidden layers. This depth helps capture complex data representations. Be cautious. More layers mean more data and computational resources needed. Now consider hyperparameters. You'll want to adjust the number of neurons and layers, learning rates, and choose suitable activation functions. It's also important to understand different types of neural networks. Feed-forward neural networks, FNNs, are excellent for simple tasks. CNNs are best for images, while RNNs excel in handling sequential data. LSTMs are designed for capturing long-term dependencies. Transformers, on the other hand, are perfect for processing language due to their self-attention mechanisms. Choosing the right architecture based on your business problem is key. For image-related tasks, use CNNs. For sequential data, opt for RNNs or LSTMs. Transformer networks shine in NLP tasks. Lastly, let's consider a real-world example, a retail company looking to recommend products. You could create a neural network-based recommender system using a feed-forward neural network. By processing customer purchase history, it can suggest relevant products effectively. In summary, neural networks are powerful tools for estimating complex functions in machine learning. Different architectures like CNNs, RNNs, and LSTMs cater to specific data types and tasks. Choosing the right architecture ensures efficiency in solving business problems. Always adjust hyperparameters for optimal performance. Now it's your turn. Apply what you've learned today to your projects or studies. Experiment with constructing and training your neural networks. Don't hesitate to revisit this guide as you dive deeper into the world of deep learning.